DevOps engineer for ZKV. A quick plug for ZKV. We are a proof-of-stake validator. We do other things among ZK proving, shared sequencing, and also invest in ZK projects, but also any other kind of project in the blockchain space that we feel excited about. Cool, so decentralizing validator sets. Well, if you think about it, do we really need to? Do we really need to decentralize further, right? If we look at kind of the reasons for decentralizing, it's reducing trust, deterring the ability to control certain network, which might have hundreds of millions of dollars of liquidity on it. Stability, you might not, we care about certain stability in networks. Certain networks have been down in the past. I'm not sure if you've ever had issues trying to send transactions and it just not working. So it's cool to have a level of stability in networks. Resource distribution, so like if we look at the amount of compute that's on the networks, it's quite important to have a certain level of compute, which one validator or one node might not have available. So that you can kind of collaborate with other nodes in the network to still do certain things. That's kind of what ZK proving to an extent does, depending on the networks. So how do we kind of decentralize now, right? So there's many validators in certain networks. So there's networks like Ethereum that have hundreds of thousands of nodes, but there's also networks, mainly in the Cosmos ecosystem, that only have 100, for example. So it depends on the network, but usually there's many validators. In Ethereum especially, these validators are actually, so there might be hundreds of thousands of validators, but there's not that many nodes, because you can actually run 30, 50, 100 validators on one physical machine, meaning that every next validator that you add is not going to add much decentralization to these networks. A lot of staking currently happens through major staking protocols like Lido, also not necessarily helping decentralization the moment that you stake with them. You get yield and you get tokens through them, but actual decentralization doesn't really, you don't really contribute to the decentralization of these networks. At-home staking has been talked about a lot in the last in the last year or so. I'll get back to that in a second because it's actually quite an interesting topic. Yeah, so as you can see, I took a screenshot yesterday of the amount of Ethereum validators that we have now. It's over 1 million. I question myself why we need 1 million validators on Ethereum. Is that really necessary? There's other protocols or other systems out there that don't have that amount of validators. And especially if you look at kind of the distribution of where these validators come from, a lot of it is from Lido, a lot of it's from Coinbase, Binance, Kraken, Rocket Pool, etc. Meaning that every kind of extra stake that you put through one of these entities or through one of these protocols doesn't really add that much to decentralization, because you're just adding to one party and making that party bigger, especially if you look at things like Lido, for example, or Coinbase if you stake through them. So yeah, what is the actual problem, right? So there's actually limits to peer-to-peer networks. I'm not sure if you've ever run into them, but there's been a study by the Ethereum Foundation that looks at the amount of validators in the network and when it would potentially grind to a halt. So if I recall correctly, at DevConnect in Istanbul last year, they talked about 1.6 million validators. You would start to run into limits of peer-to-peer networking and actually having issues with sending messages on time and getting around the network as fast as possible, because you need to kind of get these messages like transactions or even just publishing of blocks to other nodes as fast as possible. Also, the benefit of the next validator, as I kind of have named it, which is kind of what I referred to before, is if you add more stake or one more validator to the network, how much more security or how much more trust or how much more decentralization are you actually going to gain? It depends on the networks, but depends on which network we're talking about. But in Ethereum, especially, there's not that much more to be gained by one more validator, because it's already over 1 million, right? So what does one more validator add to that? Also, especially on Cosmos ecosystems, 80% of the stake is most of these networks have 80% of all the stake that is staked against validators within the top 30 of all those validators. That means that those top 30 have a lot of control over the network, but also usually those top 30 are trusted companies or trusted entities that have run nodes on many different networks for years or even decades at this point. So this kind of a question whether or not that's a problem. I personally don't think it's a problem as long as these entities are trusted entities and you've looked into them, or you know the people behind them, or you've seen what their infrastructure looks like. High fidelity time, it's kind of referred to with the peer-to-peer network limits as well. The moment you start running that many validators, you can run into limits. You can get issues with fidelity time, right? Like Ethereum has a fidelity time of 7 or 14, many minutes, while Comet BFT-based networks have fidelity times of seconds, usually. There's even examples of Noble, for example. It's a stablecoin issuing chain on the Cosmos ecosystem that has less than 1 second fidelity time, and that's like you start running into like Solana territory at that point for like speed, which is pretty cool. So what are potential solutions to this, right? So we've kind of looked at the problems. How are we going to fix all of these issues, or do we even need to? Well, Ethereum is working on something pretty cool, and they're actually launching this in the next upgrade, which is the EIP for increasing the max effective balance. Let's see, that ended up quite small, but you can kind of get the picture. On the left, you can see there's 5 different stakers. They all have one validator, which is 32 ETH running, meaning there's 5 nodes on the network, and they all have one validator running on them. Well, actually, what's happening is the middle part here, which is we have one node, or we have 3 stakers, but one of those stakers actually runs 3 validators on one node. So what does having one more, and that's actually possible. This is what a lot of people do. Even we do this. So what does having that one extra validator on top of, like, what if staker 1 here adds 1 extra validator? Does it add anything? Not necessarily, because you're just adding 1 more validator to the network. You're adding some economic security, but with the amount of validators that are already there, it doesn't really add much. So what they're working on is something that's to the right here, which is a model where instead of each staker having to run multiple validators to stake a large amount of ETH and actually gain yield from it, they are working on raising the max effective balance to actually 2048, if I remember correctly, because they might have changed it recently. They keep talking about it in the dev talks. But the 2048 would mean that all these validators that are, or all these nodes that are running 10 plus validators on one node could just consolidate that into one validator. It would mean the amount of peer-to-peer traffic that you would need to send, aka all the attestations for every single validator, would decrease significantly. So that would in theory help lower the amount of validators on the Ethereum network and maintain stability. So something that has been kind of in the development for a few years now is light nodes. So light nodes are, the way I think about it is, instead of having to use an RPC endpoint from a, hopefully an entity that you trust. So there's RPC endpoints from entities like, let's see, Coinbase or Polkashu or et cetera. Usually those are, trusted entities, but it would be cool if you could actually run something yourself without it having to take up a lot of resources on your computer or having to sync for a really long time, et cetera. So people have been working on a thing called light nodes. So what's pretty cool about light nodes is it downloads, stores, and verifies just the headers of a chain, but by just downloading and verifying just those headers, you can actually run your own RPC endpoint while it's still being a very lightweight thing to run. Like you can run it on a browser. You can run it on your phone. I've run this on my phone. It's pretty cool. Yeah, and it actually syncs pretty fast as well. It takes a while, of course. It depends on the chain, but Celestia has implemented this on their side. And actually, so what you see here is a screenshot from an Explorer that is specifically built for Celestia that you can just run a light node on the website, and it will just use that light node as its data source. So it's really cool. You don't need to use their RPC provider. Like you having to trust a centralized entity. I kind of call it Web 2-like RPC providers. So yeah, you can kind of trust but verify yourself. You don't have to rely on anyone else. So at-home staking, I think this is for me, this is a bit of a controversial topic because in my opinion, I don't think that this is going to solve any issue. These teams might not like me after this, but a lot of teams have been working on at-home staking, so like SSV, Nectar, Obol, some others out there that have been working on specifically DVT technology. It stands for Decentralized Validator technology. It's a bit of a weird one. So kind of what decentralized validator technology actually is it allows you to run, in most of these networks, allows you to run an Ethereum validator, but only with one ETH staked. So what that means is you're collaborating with 32 other at-home stakers to run one full Ethereum validator. And you could do it at home. And the reasoning for being able to do it at home is if a validator goes down, so let's say your power cuts out in your house or your internet is out for a day, those other 31 nodes that are kind of on that small network that's running one validator will make sure that you still keep signing. So users like threshold signing, you can kind of see it in the picture here, but it's a bit technical. Most of the time, as long as the majority of those nodes are online, the validator still runs and you'll still earn a yield. Although this system's built in to incentivize you to keep your node running at all times, of course. So my question to this is, to what benefit is it to run one ETH validators at home? Right? We're going to add a lot of stress on peer-to-peer networks by running all these nodes on the network. So running one ETH validators means that you're adding 32 nodes onto the Ethereum network just to run one extra validator. Again, how much benefit are we adding to these networks by running that many nodes with that much peer-to-peer traffic just to add one validator worth of economic security. So yeah, I said no extra economic security, slightly no extra economic security because one validator doesn't really add that much in this scenario because we already have 1 million. And to add to that, if you stake one ETH, there's actually not that much extra yield. You're not going to earn that much yield. Most of these people that run these nodes at home are going to do it for fun. They're not going to do it to earn a lot of money. If you want to do that, it's actually more beneficial to stake with Lido or with Coinbase because they can incentivize you further with different tokens or other token incentives, other token structures to help you gain a higher yield. Cool. So another issue with decentralizing validators is geographical decentralization. So this is the thing that I'm very passionate about is almost 1/3 of all Ethereum nodes are located in the US. So what happens if actually it's quite worse because if you zoom very far into this map into specifically Virginia, you're going to notice that this one state in the US and this one town in the US runs a very high majority of all those nodes, mainly because of these cloud providers that are all located in that one geographical area, and that's their default kind of cloud location. So US East 1, you might have heard of it. So Google Cloud, AWS, and there's actually Hetzner, who's mainly in Germany and in Finland. But actually, if you look on this list, you see Germany as the number 2 and Finland as the number 3. So a lot of people are running their validators on cloud infrastructure. There's some danger with that. The moment that these cloud providers either say, hey, we don't really, from a legal perspective or whatever, we don't really want to be involved in these blockchains, we're going to start kind of kicking all the validators out or everyone that runs blockchain infrastructure out for whatever reason, right? It could be PR drama, it could be whatever reason they decide, legal issues, for whatever reason. If they do decide to kick people out, all these validators, all these nodes are going to have issues, and everyone's going to have to scramble to start running their node somewhere else. Which actually, that would, if you think about it, that would kind of be a cool thing to see happen, just to kind of see all this geographical decentralization spread out a bit more. So I actually did a cool study, not that deep, but kind of good enough to get some interesting results. Which is I looked at our validator nodes and the peers that it had. So I kind of pulled the list of peers that our validators have or our nodes have, and looked at where the IP addresses that we have as peers are located within Europe specifically. So there's kind of some standouts here, mainly Germany, probably because of Hetzner, but also a lot of staking providers and other validator entities like to run their nodes in Germany. There's certain reasons to that, but a lot of that's also cloud. So France is also a big one. OVH is located there. Again, cheap cloud providers. So a lot of people are going to be are just going to take the cheap route and going to run on those cloud providers there. So Finland also had some location. They run there, and the UK. I think this kind of, at least me, it didn't really surprise that much. Ireland mainly for SUI, but that's just for. I looked at the amount of. I looked at it by stakes, not necessarily per node. So it could just be that there's 2 or 3 validators there that just have a massive amount of stake. So yeah, I thought this was pretty cool, mainly to see that Germany is just very overpopulated with validators. So actually, I've been working on a project to run our own nodes co-located in Bulgaria. Some cool reasons for that. Barely any other nodes. If you looked at the previous slide, Bulgaria was highlighted mainly because there were barely any other validators or kind of nodes located in Bulgaria itself. So they made it kind of a cool pick from a decentralization perspective. The internet speeds here are just outstanding. It's located in an area where it has amazing connections to both Western Europe, where a lot of the major internet exchanges are located, and to the Middle East and beyond to Asia. So it's just really well located for an internet kind of centralization perspective. There's a high level of technical expertise here. Great universities, especially in Sofia, means that if we ever have any issues, I don't need to physically go to Sofia. Although I live in Bulgaria, but I'm not geographically very close. So it's cool to have a very technical team that we can always contact to solve any issues for us. And it's a good investing climate, in my opinion. I definitely see Bulgaria being a good investment in the long term. Cool, so what are next steps for decentralization? So I'm personally, and kind of from a validator perspective, working on encouraging other validators to dive a little, or look a little harder into their choices of where to run their nodes, right? It's easy to pick Germany, it's easy to pick Switzerland, it's easy to pick the UK, or easy to pick the US, or wherever else you're looking into running your validators or your nodes for the different networks. But to kind of help decentralize these networks and to prevent any government or any internet service provider from causing you any issues by being able to kick you out or whatever, it does actually make a lot of sense to look a little further than those countries. So I actually know a lot of validators that are now looking at Estonia and other Baltics. So yeah, there's some stuff happening, but even those countries are geographically actually quite close to Finland, for example. So if we want to kind of spread out for where all the users are and where people are that want to actually use the networks, it makes sense to look at where people are actually using these networks and do they how much do they use these networks and what's the closest node to them. So it might happen that the closest node that someone's running for a certain network is actually located quite far from that center of usage. It's like Cello is a good example. They have a lot of usage now in Africa. Recently, they've really taken off in the amount of wallets that are being created there and are active there. But there's not that many nodes located there. So they ran into issues, and people are launching other nodes in closer to those countries in Africa where people are using it. And I think that we should put an emphasis on light nodes versus home staking. Home staking is cool to test the waters with staking, or like running a node yourself, running a validator yourself. But in the long run, light nodes, in my opinion, are really going to kind of help decentralized networks further, kind of for all the reasons I mentioned earlier. So there's some other concepts in the blockchain space that are working on decentralization. So sequencing for L2 networks has been a big thing recently. So a lot of teams are working on shared sequencing. TLDR of what that is an L2 needs a node to kind of combine or like to collect all the transactions, create the rollup, and post the data that it needs to post to an L1. A lot of these networks have just run that themselves. So like Polygon has kind of been one that just ran nodes themselves to do this. They didn't really work together with other entities. But there's like a centralization risk there, right? Well, one, if their nodes go down, what happens? And two is if they really want to block someone from doing something without that necessarily being there being consensus within the community, that's a good thing. They could. So yeah, shared sequencing is a cool idea to help decentralize these networks, or decentralize these L2s a bit further. ZK proving is a big thing recently, at least in my space because I work with it. But it's pretty cool to see that these ZK rollups are kind of starting to really get into production, but there's still an issue with the actual proving of those ZK rollups. Shared proving networks are kind of helping with running provers, and those are actually very computationally intensive as well usually. So like we're talking like GPU proving, kind of going back to a little bit of the mining era, but still in a very cool and interesting way. Also, there's recently been a push in better tooling for high availability for validators, which that doesn't necessarily add to decentralization, but it does help make sure that all the nodes or all the validators that are in the network actually stay online, or like stay online, or that nodes are incentivized to stay online quite a bit further and longer. So like if there's an issue on one node, you can have a second node that still keeps signing while there's something on top that helps prevent double signing, etc. Cool. So that was it.